All right, so this is the second page of your number 62 homework. We skipped over 4 and 5. So number 6, find the volume of the solid generated when R, so this is the diagram from the previous page, when R is revolved around the horizontal line y equals 8. Okay, so the horizontal line y equals 8 is going to be up here somewhere, right? And so what we want to do is we want to find out what this, what this area is, and then pi r squared it, right? So it revolves around here. Now the outer function will be this f of x1, and the inner function will be this g of x1. So we'll have to use those as well. So let's find out what the integral is that represents this solid when just r is revolved around this line y equals 8. Okay? All right, so the volume is going to be, it's pi r squared. We're talking about we're doing a series of these disks or washers. So it's pi r squared. So we have the pi as a constant out there. We do need an integral. And we need to find out sort of what this, r begins here, I guess, at x equals 0. And then r ends over here at x equals this intersection point. So we're going to go from 0 to the, we've done this, I think, already before.
0.17822.
Yeah, okay. All right, so these are the two graphs here. The 4 to the negative x is going to be your g of x, and your 1/4 plus sine of pi x is going to be this one here. So type those out onto your graphic technology and find your intersection point, which should be, what is it again? You want to list that out for me?
0.17822.
Okay, so 0.1782 or thereabouts. All right. Okay, so now the outer function from this axis is going to be the f of x, which is going to be right here, 1/4 plus sine of pi x. And we need to subtract the axis of symmetry, which is y equals positive 8. And we need to square that. Then we will subtract this part. That's going to be blank space, right? We need to subtract this part. So that part is going to be the g of x, that's the 4 to the negative x function, minus the axis of symmetry. And again, I can't really stress this. I've mentioned this before, but what happens when we subtract this 8 for both of them? It's like we're bringing both functions down 8 units, right? This one down to here, and then this one, down to here. So we're bringing everything down so that this is like a new rotation, axis of rotation, right? It just kind of brings everything down so we can rotate around the x-axis without actually doing that. So that's why it works. Okay, and then dx. How's that look?
Square.
Miss the square. Thank you very much. That's what I'm looking for. Okay, good. Joint effort. All right, so go ahead and pump that into your graphing technology. Let me know what you get. Okay, so you should get 2.979, and I will challenge you to do number 7 on your own here. Do number 7 on your own the same way. You just have a different axis of symmetry. So go ahead, or symmetry of rotation, I should say. And then this is the next question in your notes package that I've given you. So I would like you to try this one. This one is a challenging one, okay? But this is an AP style free response question. So see what you can do with this. I believe these are all d-axis. So yeah, I believe that this is rotation around a horizontal axis. So this one is a bit tricky. I want you to give this one a good honest try, and we'll maybe talk about that tomorrow. And then we'll talk about rotations around vertical axes in our next lesson, okay? All right, so finish this question number 7 and do this one for class tomorrow.
That was easy.